Hey friends, you're watching BrainStormAcres. I'm Henry. I'm taking the next step in building this jewelry tray for Irene's business. It's a case that she'll be putting silver in so that people can see it, but they can't necessarily walk off with it real easily. We were kind of concerned about whether or not these LEDs were putting out too much light, and several of you made comments that it's too bright. Well, we think we agree with you, so I'm going to do something different. Several people commented that we should put a dimmer on these LEDs, but putting a dimmer on LEDs is no simple task. There's a lot of different ways to make LEDs work, and just having voltage is not one of them. So the usual way that you dim a light is you use a rheostat or something else to reduce the voltage. LEDs don't work that way. You need a certain amount of voltage to turn them on, but the physical process of generating light from an LED is slightly more complicated. It's really not important to go into that now, but it's enough to say that it takes some special dimming circuits to dim LEDs. Well, I've designed such circuits before, many times, and I've used them. But I found an online source for some inexpensive 12-volt pulse width modulation circuits. Now these are sold as motor drivers. They can drive about 3 amps, so it's not a lot of current, it's not a lot of current capability, but it's more than enough to light up these LEDs. Now you may notice this is in a plastic package, and you may wonder why. It's a cool little package, but it's also special. Here, I'm going to cut one end off. A little knob for this circuit just fell on the table. But what's special about this plastic package is that it has anti-static properties. And that's important when you're dealing with integrated circuits like what's on this board. Now, this board cost me about $8. There's more than $8 worth of parts on this board if I were to try to build it myself. So even though I could build it, rather than spend the time, I decided to go ahead and spend less money and less time by buying it online. I bought 2 of these just in case I decide to convert the other jewelry case to having LEDs as well. Well, if you've been around electronic circuits, you know that you really shouldn't be handling circuits that are subject to static damage. That's why this packaging is used. I have a pretty good idea about what's on this board, and I'm not running a big risk by handling it this way. But if I were in an environment where there was static electricity buildup, I would want to make sure that I was actually grounded. There's a ground strap that you can buy that then has to be hooked up to ground somewhere in your lab, your workshop, your house, wherever you're working. That's a bit of a pain in the neck, so I'm just not going to do it. I'm going to run the risk that I might accidentally zap this. Now there is a heat sink on here, and that's to control the power device that's on this circuit board. I mentioned this is a pulse width modulated motor driver. It has a 3 amp capacity according to the instructions, and I only need about 2 to power the entire set of LEDs that we started off with. And probably less than 2 will do fine for what's in this box. I've pre-wired one of these circuits up. It's a bit of a pain because I'm only trying to do this on a temporary basis to try it out. If I wanted to really make this work right, which I will, assuming this works, I would mount this in a watertight box. I would have the connections between the LEDs and these little circuits permanent so that they wouldn't be able to come off. But let's go ahead and give it a try. Hey, LED light. Now let me see if I can turn the brightness up and down. There I am, increasing the brightness. This is currently pulling 2¼ amps, which is less than the 3 amps that the circuit's good for. But if you look, you can see I can get full brightness out of these LEDs, and I can reduce it to whatever level I want. Now, if you could actually see the meter over here, you'd notice that the amperage, that's how much power is being used by this circuit, is reducing. As I reduce the light level, the amperage drops down and down and down. Right now we're sitting at 0.05 amps versus 2¼ and I can keep dropping it down. That's as far as it goes. Well, that's plenty of light if there's nobody really trying to look at things, but if they are, we can crank the light intensity up as far as they want. I can drop the light level down very, very low. This would be fine if Irene's shop is open when it's dark. You can still see there's something there. We can always turn up the brightness all the way until it's just as bright as it can be. Pulse width modulation. How does pulse width modulation work? LEDs work on a certain voltage level. So I can't go changing the voltage itself. So how do I reduce the intensity? It's able to be done several different ways, but the easiest way is to use a circuit which is going to turn the DC power off and on. And that's what this motor driver does. How long the DC power is left on to the LED and how long it is turned off determines the brightness that you're going to be able to see. It does that by switching very fast. The human eye can detect flickers somewhere around a frequency of about 25 times per second. So if a light's going on and off that fast, that's right around what's called the fusion point of your eye. A lot of systems now have higher frame rates, higher turning off and on, like 60 times. If you have really exceptional vision, you'll be able to see some artifacts at lower frequencies. And we may even have some show up in this show because the camera is taking a picture at a certain frame rate. If the frame rate of this motor driver and the frame rate of the camera happens to coincide at the right time, you'll see a dimming and flashing of the light. We'll see. Sometimes spending time to complete something like the digital vacuum wax injector project is really important because you can save a lot of time and a lot of money. Now, the time that you save in that project isn't getting it set up, which is what I'm doing right now. It's during the actual production. So yes, I'm spending time on the front end, but that will be more than offset by Irene saving time in the studio. Well, the same thing goes with designing a circuit to turn on the LEDs and to control the light level. This is a pretty simple circuit. In order to finish this, I'll be making some more permanent electrical connections here on this terminal block and putting this into a waterproof, watertight container. And on one side I'll have the ability to plug in 12-volt power. We have a lithium iron phosphate battery that I built a year ago that can be used to supply 12 volts to this module. We just need to have the right voltage and the right frequency so that things work the way we want them to work. As you could see from the demonstration, I think we have a very good solution for having the right level of light. You know, Irene's down in the studio and it's time to go out and recheck the rat traps. We checked this morning. I think we have some footage from game cameras in the greenhouse that I'll show you. But we didn't catch them last night. We'll try again tonight. We've tried a bunch of different baits. So far, that little beggar is avoiding all of those baits. We're going to go back to an old standard. We may be using some peanut butter. We could try using some stinky cheese. Irene and I will talk about that, and then we'll bait those rat traps up and give it another shot. Well, thanks for watching. Don't forget to hit like, subscribe, and ring the bell for notifications because we're doing a lot more stuff. Projects are getting cleared up. I have more to do here on the vacuum wax injector. I have my TIG welder to deal with. I just got some more parts in today. So we'll be doing more stuff. We'll talk with you later. Bye.